Hey, ladies and gentlemen, I'm here today to show you how to create a feedback loop. We're going to be doing an example together. I'm going to be reading to you a little bit about cardiac rate and how it's controlled both through the parasympathetic and sympathetic nervous system. And then I'm going to show you how to put that information onto a feedback loop so that you can make your own. Your goal today is to be able to fill out your own feedback loop that looks just like this using a feedback mechanism that is not cardiac rate. You're going to pick something else that you're interested in learning more about. So I'm going to start here with this. This is a quick reading about cardiac rate. And I'm going to read it together, and then we're going to talk about how we can use this to fill out our feedback loop. So heart rate is controlled by two branches of the autonomic, which is involuntary nervous system, the sympathetic nervous system and parasympathetic nervous system. The sympathetic nervous system, which is abbreviated SNS, releases hormones like catecholamines, epinephrine, and norepinephrine to accelerate your heart rate. The parasympathetic nervous system, or abbreviated PNS, releases the hormone acetylcholine to slow your heart rate. Such factors as stress, caffeine, and excitement may temporarily accelerate your heart rate, while meditating or taking slow, deep breaths may help to slow down your heart rate. Exercising for any duration will increase your heart rate and will remain elevated for as long as the exercise is continued. Regular participation in cardiovascular exercise over an extended period of time can decrease your resting heart rate by increasing the heart size, the contractile strength, and the length of time the heart fills with blood. So what we're going to do is we're going to use this information and turn it into a feedback loop that's a visual representation of the heart rate either increasing or decreasing and how the body can affect change to bring the heart rate back to a set point or resting heart rate. This article is just a snip from UC Davis Health and Sports Medicine. There's some big words in there relating to hormones like epinephrine, norepinephrine, acetylcholine. But the idea is that I'm able to read this and take from it a big idea about how homeostasis works in my body. So what am I going to do with this information? I'm going to put it on my feedback loop. Okay, so this is the same draft that you're going to have or that you should have in front of you. And what you're going to do is you're going to edit it in a way that shows a feedback mechanism visually rather than in a written paragraph form. So I've chosen heart rate. So I'm going to put down here for homeostasis, I'm going to say homeostasis is a resting heart rate. That's what we call homeostasis. Okay, it's whatever I'm looking at in terms of balance. Now, what I want to look at is heart rate and exercise because that's what we just did in our lab. So I'm going to either choose what happens when I exercise and how does my body bring my heart back down to resting, or I can look at what happens when I'm resting and then my heart rate goes up. How do I bring it back down? So I'm going to do for my stimulus here, I'm going to say exercise increases heart rate. Okay. So if I leave homeostasis, my body can only have an elevated heart rate for so long before it needs to return to resting. Now, I can, depending on my fitness level, a lot of people can keep their heart rate up for a very long time, but eventually the body is going to have to reset and bring the heart rate back down to resting. It's damaging for the heart to continue to beat really fast because those muscles, again, the heart is made of a muscle, it gets really tired. So I'm going to look back at my article here and see what happens. What does the body do when my heart rate needs to slow back down? So I did a little highlighting before to kind of get ready for this. So I'm looking at what are some things that can slow the heart rate. I'm looking right here. The hormone acetylcholine can slow the heart rate. So I'm going to go here and I'm going to highlight the hormone acetylcholine can slow the heart rate. So after my exercise stops, this hormone can be released to try to slow down the heart rate. So I'm going to copy this. And then in my feedback loop, my reaction, whoops, let me get that back down to like a normal size. And put a little H there and get rid of this highlight. Okay. So the stimulus is the exercise increases my heart rate. The reaction, my hormone acetylcholine is going to slow the heart rate. The heart rate decreases until it reaches resting. And then I'm going to kind of reset the fonts here so that it looks nice. Check my spelling here. Okay. And so essentially, it's just a quick way for us to kind of look at what happens when the body leaves homeostasis. So once again, our stimulus, exercise increases the heart rate. We can leave it out of balance for quite a while before we need to bring our heart rate back down. So what happens as soon as we stop to exercise? The hormone acetylcholine is released to slow the heart rate. And what's the effect of that hormone? The heart rate decreases until it reaches resting. So I might even change this reaction here where it says hormone acetylcholine. I'm going to say hormone acetylcholine is released from the endocrine system. That gives me a better idea of where that hormone is coming from. And then that leaves this space here where it says effect. The effect should really be what's the effect of that reaction. Now, here's the thing. You guys can make this look really nice. You can change the colors here. You can change the fonts. I even had some students last year that added some pictures to make this look really great. Now, once again, for your loop, you are not picking cardiovascular rate. You are not going to be doing the same one that I'm doing. You're going to choose some other system in the body that needs homeostasis. I'm going to give you some examples really quick of some work I saw last year. This is Monse. She chose to do the blood clotting factor. So she chose to do, you go outside and scrape your knee. What happens as a result of a knee scrape? Your body begins to clot to form a scab, and then the wound stops bleeding. So she did a wonderful example here of picking something that she's interested in. She chose blood clotting, and she included some pictures here. I really loved what Monse did. Maria here kept it pretty simple. She chose living in a hot or dry climate causes nasal membranes to dry out. So homeostasis would be nasal membranes. She chose living in an environment where your nasal membranes dry out. Okay, and then Max, I really love Max's. He chose feeling pain. What's the point of feeling pain? What does that do for our body? How does it control our body's reactions to different stimuli? I love how Max included pictures in his. He said that for his stimulus here, hurting any part of the body and feeling pain. And then what happens when we feel pain? The pituitary gland and brain send out endorphin hormones to reduce the perception of pain. So what's the effect of pain? We feel it, and then we need to go get that pain to go away. So he's talking about the involvement of the pituitary gland here. Now, once again, I want to remind you that these students put quite a bit of time and research into finding a topic that works for them. So once again, I've chosen cardiac rate because it just goes along nicely with our lab. And what you want to do is think about some system in the body that needs to remain in homeostasis. It could be internal body temperature, like Max did. It could be something regarding pain or the nervous system. You could think about food, digestion, hunger. The choice is really up to you. And if you're feeling like you can't think of any examples, you're welcome to shoot me an email, or you can run an idea by me. But students typically have a really fun time with this. You can look back on any of your CK12 readings with body systems, or you can think of something brand new and research it yourself. Once again, you're choosing something for yourself that you want to learn more about, and you are going to be doing a feedback loop on that system. So once again, you should be at this time opening up your own feedback loop. It should be attached on Google Classroom. Hopefully that's where you found this video, and go ahead and get to work, you guys. Have fun.